Okay, so the Northern Manitoba, I'm sure I should have put Trappers in here, festival held in the past originated in 1916. A championship dog race has always been a significant part of the festivities. In the early days, the race was non-stop from the pass to Flin Flon and back. In one particular race, the total distance was 140 miles. Conditions were excellent on the way to Flin Flon. However, bad weather caused the winner's average speed to decrease by 6 miles per hour on the return trip. The total time for the trip was 8.5 hours. What was the winning dog team's average speed on the way to Flin Flon? Okay, so let's just remind ourselves that our distance formula is distance is equal to rate times time, or if you're in physics, it would be velocity times time. Or time is equal to distance over rate. And if you remember your triangle from science, you can use that too. That the distance is equal to, we're going to use v for velocity, is equal to velocity times time. Okay. Okay, so we want to know what was the winning dog team's average speed on the way to Flin Flon. So we're going to use that to determine our let statement. So we're going to let x represent the average speed, okay, which in this case is miles per hour, from the pass to Flin Flon. Okay, now once again, it's helpful to have a chart to help organize your information. Okay, there's two parts to this trip. There's the trip to Flin Flon. Okay, and there is the part of the trip which is the return. Okay, so you're going to use the information from the word problem to fill in the chart. You know that the for this race that we're looking at, that the total distance was 140 miles, so that means you're going to go 70 one way and 70 the other. Now, their velocities, we don't know what that is, okay? We want to know, though, what the average speed was from the pass to Flin Flon, so we're going to call that x. We'll put that here. We know the return trip was slower because the weather was bad. So the speed was decreased by 6 miles per hour, so we're going to write x minus 6. And we don't know what the time is except to say that the total time is 8.5 hours, so that's total time. And we're going to write that as 17 over 2. Okay. All right, but if you take a look on our chart here, if we want to figure out what time is, because that goes in our last column, time is the distance over the velocity. So we're going to write for the trip to Flin Flon as the time being 70 over x, and the return trip from Flin Flon as being 70 over x minus 6. Okay, so how can we determine our equation? Well, we know that if we were to add the time to Flin Flon to the return time to the pass, we would get total time. Okay, so that means we would go 70 over x plus 70 over x minus 6 is equal to 17 over 2. All right, so we need an LCD. Our LCD is going to be 2 times x minus 6, or if you like, 2x times x minus 6. And our non-permissible values are that x can't be 0 and 6. Okay, so let's multiply the different parts of our equation, the left, the middle, and the right, by our LCD, which is 2x times x minus 6. And so we times 70 over x by that, and then 2x times x minus 6 times 70 over x minus 6 is equal to 2x times x minus 6 times 17 over 2, and it's getting a little crowded here, so let me move this over. Non-permissible values, x can't be 0 and 6. Okay, so let's reduce what we can. Okay, we can reduce an x over here. We can reduce an x minus 6 in the middle, and on the right we can reduce a 2. Okay, so what are we left with? We are left with 2 times x times 70 plus 2x times 70, which is equal to, let's say 17x times x minus 6. And so we get 140x plus, oh, I forgot something, didn't I? We want to go 2 times x minus 6 times 70. Okay, so that gives us 140x minus 840 plus 140x is equal to 17x squared minus 102x. All right, notice you have a quadratic. So you want to make everything equal to 0. So we're going to go 0 equals. We're going to bring everything over to the right because I want my x squared term to be positive. And I get 17x squared minus 382x plus 840. All right, now this is factorable, but like I said in class, if you didn't feel that you could factor this, you can always use the quadratic formula, right? Which is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, but I know it's factorable, so I'm going to factor. And I get 17x minus 42 and x minus 20. Okay, so when I solve for x, the first factor that I get, or sorry, the first solution that I get is 42 over 17, which works out to 2.47. And then x equals 20. Okay, so here are two possible answers, 2.47 and x equals 20. Now, neither one of them conflicts with our non-permissible values. So let's see how they work in our chart. Now, we know that x is the average speed in miles per hour from the pass to Flin Flon. So on our chart, that means it's right here. So let's say x equals 20. Then 20 minus 6 will give us 14. Okay, so that seems to work. Let's try 2.47. If x is 2.47, then we're going to get 2.47 minus 6, which gives us negative 3.53. Now, we can't have a negative rate, can we? So we have to reject this. Okay, 2.47, and so our answer is 20. Okay, and once again, you can check that out. Okay. Let's just plug it in over to here and see what we get. Okay, we know that our total time should be 8.5 hours. So if I put in 70 over 20, okay, I get 3.5. And if I get 70 over, okay, and I worked out x minus 6 to be 14, then I get 5. Okay, and does 3.5 plus 5 equal 8.5? Yes, it does, so you know you're right. Okay, and so then you write yourself a sentence. The average speed from the pass to Flin Flon is 20 miles per hour. Okay, and you're done.